Advances in semiconductor assembly and fabrication are offering medical device designers new options for smaller, more compact, and more sophisticated designs. Modern surgical devices require a small, non intrusive footprint, often with onboard chips, rigid or flexible substrates, and 3D stacked components. And there's often a requirement for integrated optical components and precision placement within plus or minus 5 microns, often on a 3-axis mount. And the entire apparatus needs to be sterilizable and hermetic. A recent project at Promex involved a new approach to endoscope design. This is the traditional device used for doing laparoscopic surgery. That black cable connects the sensor head that goes inside the body to a screen or optical viewer. This is the traditional method that's been used for decades to look inside the body. In a traditional endoscope design, there is an optical chain that uses what's called an image conduit composed of a series of optical fibers and spacers. So, a few million fibers that are all in parallel to carry the image from the lens to a camera or an optical eyepiece that the surgeon looks through to see what's going on. So, you have a relatively large device with both a good deal of complexity and issues with image quality where the surgeon is essentially working through the eyepiece of a microscope. A client came to us with a request. They said, hey, we'd like to build an assembly that would replace this functionality with a miniature high-definition stereoscopic TV camera. Help us figure out how to make such a thing. Can we move the camera to the tip of the endoscope? This would create a sharper image, a simpler optical chain, and a device that would be smaller, thinner, and easier to handle. So that was the original project that we got started with. And this is a more extraordinary version of the concept, a capsule endoscope made with all of the optics, image sensors, and electronics stuffed into a package that a person literally swallows. And this device goes through the intestinal system and sends out either an RF signal or internally records a video of what the image looks like as it passes through the digestive tract. Such a device must have a series of unique characteristics. It needs to be able to be assembled at scale and be very robust, taking some amount of mechanical and physical abuse, and it has to withstand sterilization. So this requires working through a portfolio of fabrication and assembly capabilities to develop the optimal approach to fabricate such a device. A key feature here was the use of 3D assembly of the optical and semiconductor components into a stacked configuration to pack more function into a smaller space, and a range of assembly technologies to fabricate the final camera. Techniques such as flip chip, waterfall bonding, or even more advanced techniques such as on-chip through-silicon vias or TSVs. These are vertical electrical connections designed to pass completely through a silicon wafer to facilitate three-dimensional assembly. And this is what the final 3D stacked camera assembly for the endoscope looked like. There's a lens at the top that's covered by glass and an image sensor that creates a miniature video camera. And the entire assembly is just 8 millimeters across at the substrate, forming a 4,000-line stereoscopic camera in full color. An assembly with incredibly close dimensional tolerances that's the size of an eraser on the end of a pencil. And the entire assembly is hermetically sealed and can withstand autoclave sterilization. A successful design has got to work, it has to be robust, and it has to have good economics. And we are currently fabricating these units for this client at our primary facility in Silicon Valley. So medical device manufacturing is characterized by a few key factors: being able to operate in a tight regulatory environment, lifetime bill of material and process documentation requirements, and demanding layout and size control involving mixed assembly processes and the development of stable automated manufacturing. Once such a process has been fully developed and properly documented, it typically remains unchanged for the life of the product due to the cost associated with making any modifications. At Promex, we specialize in the fabrication of complex semiconductor assemblies for the medical device industry. We understand the regulatory processes and the unique engineering demands required for medical devices. And we can bring a wide range of capabilities to help clients turn designs into manufactured assemblies that meet the client's technical, regulatory, and economic constraints. If we can help with your medical device fabrication needs or just answer an engineering question, please use the form below to reach out to someone on our engineering staff or on the business side.